Hey, hey. So let's just today I'm just gonna basically just mess around with the solar system in general. Um, so here we can see we've got the sun in the center, Mercury, Venus, Earth, Mars, Jupiter. Where's Saturn? There's Saturn. Uranus, and finally Neptune, which is out there. And there's all these obviously other bodies. Pluto, notable one, former planet, but as you can see, there's plenty of these little ice worlds out there floating around. I think, no, these must be real things. I was going to say that I'm not sure whether they were actual known things or whether they're there because we know they're there. So they've added them in to make the simulation more accurate, but it looks like they are real objects. But here we are in the inner solar system. I mean, look how different. So out here, everything seems like it's moving so slowly, so serene. So and then you go into the inner solar system and it's just chaos. I mean, look, we're at 2 years a second at the moment. I mean, look at the Earth; it's just flying around. I mean, Mercury is basically tripping out. So let's bring it down a little bit so we can get a bit more scale on the inner solar system. See, one thing that I always find interesting that is easy to forget is that the sun is also moving around the galaxy as well. So it's kind of like dragging all the. Oh, that's cool! Look at that. It's that random alignment. So when is this apparently going to happen? At 7 on the. I assume that's the 3rd of May. 2191. Let's just check I've got that. I assume that's right. Yeah, let's see how the numbers change. Yeah. So, yeah, 15th of May, 2191. Wow, I mean, look at that. And then, slowly, they should all, yeah, look. Crazy. Anyway, so let's see how the solar system reacts to shall we add a small star? So Wolf359 is pretty small, so we'll add this random red dwarf star on I can't think of the proper technical name, it's quite late at night, but a eccentric orbit, would you call that, where it's not in line with the rest of the plane of the solar system? I'm not sure. But yeah, we'll put it on a bit of a wonk so that it's going to fly in and then fly out. So the Earth now is going to have a second sun in its sky, but it's that star is much dimmer than the sun. But it would be quite visible because its orbit for at least part of the year, probably most of the year actually, it will be visible in the night sky, because it's going to be further. It's the reason why we only can see Venus in the mornings and in the evenings on the whole, because it's closer to the sun than the Earth. So every time we're looking at Venus, you're kind of looking at the sun as well. So it tends to always be in the daytime sky. Obviously not a problem for. I imagine it would still be a problem for space-based astronomy, unless you could like use the Earth as like a sunshade. Anyway, I'm waffling on. So yeah, let's put a simulation rate at a month a second. So it's gonna be like, it's gonna be slow whilst it's up here, and then it's gonna, let's center on the sun. Right, so it's gonna come down, it's gonna pull the Earth out. Yeah, looks like it's curved the Earth. If it's gone past, it's caused. So then it's going back. Right, it's also obviously having a very noticeable effect on the sun itself. They're beginning to, by the looks of things, orbit a common center. So they're going to go into orbit around each other, and they will probably get closer, and this might be quite bad for the solar system, especially if they collide. So we shall see. Okay, so yeah, it's gonna come flying back up now. Maybe. So it's orbiting at the moment. It's orbiting the sun every 4 years. It's at an inclination of 34.6 degrees. That's the word I was looking for. It's the inclination of the orbit. And as you can see, it's spiraling either inwards or outwards at the moment. I can't quite tell. I think that means it's coming inwards, but also the sun is being very perturbed by its orbit, by that extra weight whipping round. Now, this object, Wolf359, this little red dwarf, isn't actually that much bigger than Jupiter. It's only, sort of, a couple of fractions above the diameter of Jupiter. So other than being extremely bright in the night sky, I wouldn't imagine it would look very big. It would only look as big as Jupiter. It wouldn't be like the moon or the sun, which by complete and utter celestial coincidence are nearly precisely the same size in our sky, because I may have the exact figures wrong here, but it's something like the sun is 93 million times further away than the moon. No, that can't be right. But anyway, but it's like exactly 93 million times bigger, or something like that. So the two amounts balance each other out, and that's why we get a solar eclipse. And I also thought it's quite amazing how we have this, because the moon is obviously, there were times in the past when the moon was much closer to the Earth, and in the future the moon will slowly drift away from the Earth. So this chance alignment, this chance alignment happens to happen now to a planet where at just the precise time when an intelligent species exists on the planet to observe that. Oh, hang on, something is happening on the simulation. Mars, it looks, is almost completely flipped. Its orbital inclinate, so it is in absolute opposite to the most of the rest of the solar system. this Wolf359 caused problems with the bug, and it looks like it's causing a lot of problems for the solar system. How are we doing? I haven't checked in on Earth yet. Let's have a look. It's being awkward. Everything looks okay. Our lights are still on. That's always a good sign. So let's slow down the simulation. Looks like we're maybe a bit colder. Is the ice coming a bit further south? Yeah, I'd say that is because this is apparently the 16th of August, so something's changed, because the northern hemisphere is definitely a lot colder than normal for August, and by the looks of things the southern hemisphere is also much colder. I mean, you know, look, the sea ice has connected to South America. New Zealand is only a couple of hours flight now from the sea ice, but this is technically the southern winter, whereas in the northern summer we've got the Tibetan Plateau. Is it called the Tibetan Plateau? Or this big area out here, big ass area of really high ground, is completely covered in ice in the middle of August. But other than that, it looks like we're doing okay. Could probably do with being a bit colder, truth be told. So now, looks like the solar system, some object. I really want to see what happened to Mars. I can't reverse the simulation, I don't think, unfortunately. And the chances of me being able to add the add Wolf in the exact position and that probably isn't going to happen again. Right, so let's focus back on the sun so we can get a proper idea of what's going on. Oh. It looks like Jupiter being brought much. Yeah, I suppose Jupiter would be being like squished in between the sun and its companion now. So as it's being squished, it's going to be going like being squished further, like pinched closer into the sun all the time, isn't it? I mean, look at that. From the Earth, that would be pretty epic sky right now. Because think so, sun's here, so you'd have nighttime over here. You'd have like Mars, and like, yeah, it'd be cool. And I suppose Mercury isn't too bothered by the whole situation because it's so close to the sun. So anything else would have to have, you know, a lot of influence really to change it. I mean, obviously it's going to be changed slightly, but it almost looks now like things have settled down. It looks like Mars has taken one for the team. Maybe not. And its weird orbit now is kind of somewhat stabilizing things, but when you've got two large bodies, it's very rare that it's entirely stable when you've got the one, you know, they're so far away from each other, so they're both, you know, all of the objects in the solar system are being torn between two, whereas if they were, you know, if they were both more or less the closest things to each other, then everything else would just orbit them as like a single mass in the center of the solar system, and it would only be, you know, any eccentricity caused by the planets perturbing the two stars' orbits that would create issues. Whereas with this star being way out over here, like the center of this solar system now isn't the sun and isn't Wolf3, it's kind of in the middle. So everything is kind of like, well, what do we orbit? I mean, the sun is way bigger than this, so it's not much of a hard decision for these objects of which one is the main one that they're orbiting. But Wolf is able to have a lot of influence, obviously, on that system. Everything seems to have more or less calmed down. Nothing seems to be orbiting around the solar plane now, except maybe Mercury, because of the aforementioned sheer closeness to the sun. I mean, you know, anything further out, I imagine, are going to be perturbed because of the extra mass suddenly plonked in the solar system. But I can't imagine that they're going to change that much, other than the fact that the sun's kind of speed through the solar system. Lots of stuff looks like it's being thrown out, actually. See, you can never predict it. No! Oh no! And that is not good. They're like basically traveling what looks like fucking speed of light. Oh no. That is not good. Oh dear. Well, Earth is now a cold, dark, dead world, probably with some billionaires still living under the ice, waiting to die. Actually, to be fair, if you had like nuclear reactors and had planned well in advance and had like a proper decent setup, and you had population control, yada yada yada, you might be able to eke out a living, maybe, but not going to be pleasant. You know, even if you could see the sky through the literal miles of ice as the atmosphere, not just that, remember that this wouldn't just be the water freezing on Earth, this would be everything freezing on Earth, all the oxygen, all the nitrogen, all the argon, I imagine, all the CO2, everything would freeze onto the surface. So I imagine, yes, the first layer would be ice, but then as you drilled up through that, you would then get through. I think I don't know enough about how this stuff really works. I'm just a dude, but my common sense tells me that they would layer down in the density that they are, same as anything that's centrifuged. Anyway, yeah. So, and when we finally got through that ice and looked up at the sky, the stars would never look like they were really changing to, yeah, God, that would be depressing. Maybe the only thing that would change notably maybe in a human lifetime is the sun would get dimmer as we moved away from it. Yeah. out of all of the planets that could be spat out, it was the Earth. The universe is a cruel, cruel place, especially when I'm in charge. I'm very sorry, Earth. And on that note, I think we'll leave this little experiment right there.